Okay, these next notes are on Newton's method to approximate roots of higher degree equations. And what we're going to be doing now is if we've got an equation here and we want to approximate the root, okay, in other words, we really can't find the root, maybe something that may be hard to factor or impossible to factor, and we want to approximate the root, then Newton came up with this method by using tangent lines and eventually closing in on the root by using these tangent primes when there's these tangent lines when there's zero. So here's kind of an example, and there's one like this in the book, so I kind of sketched this out, but just did a few of the, or just one iteration. So we would call this, let's just say this is our function here in orange, and we want to find the root here, and let's just say we guess here at x1. We say that's the root, or that's our guess. Okay, what we do is we try to find the tangent line to the curve at x1. Okay, almost like the linearization. Well, actually, it would be the same thing as the linearization at x sub 1. Well, we know that this point here will be x1 f of x1. So how can we find the slope? Well, the slope is going to be f prime, right, of x1. So the equation of the tangent line would be y minus y1, which would be this f of x1, and that equals m, which is the slope, which would be f prime evaluated at x1, times x minus x1. So this would basically be our tangent line. So if you take a look at that and these points here, and this being the slope at that point, then you can see how this is the tangent line. Y minus y1 equals m times x minus x1. And again, we find the slope by taking the derivative of the function f of x at x1. Now, when y is 0, we're going to actually have the x-intercept of this green line, this tangent line. In other words, we said y equal to 0, then we'll have actually this, that's when y is 0, we're going to have the values will give us what x is, right, for that. So let's set y equal to 0 and solve for x. So we'll find out where this point is. When this line is equal to y is 0, that means it's the x-intercept, that means it's on the x-axis. So I put 0 in for y and leave everything else the same. And then over here we just multiplied out 0 in for y. I left this the same, then I multiplied f prime x1 times x, f prime x1 times x1. Okay. And then we just, we had this, this was over here, this f of x1 was positive, so I added this f prime x1 to both sides, and I left this on the right. So if you take a look at this, you can follow this, I hope. And then if I solve for both sides by f prime of x1, I get x. And that's what I want over here. That's the x1, y is 0. And that's going to end up being this f prime of x1 times x1 minus f of x1 all over f prime of x1. Now what I can do is I can put both these, I can break this up. Remember when it's tough, break it up. And if I write f prime of x1 over f prime of x1, the f prime of x1's become 1, so I just have x1. So this part of the fraction becomes x1, and then minus f of x1 over f prime of x1, and that ends up being my value for x. And that's my new x, so that would actually be x2. And then we could do that again, and we could use x2 and put it in the formula, and we would get a closer approximation of the root. Then I could use that again and close it, and I could keep doing that over and over, and I would get closer and closer to the root. Okay, so in general, if I want my next x, because this gave me x2 for x1, so if I want xn plus 1, if I want the next one, I would just say it's going to be x sub n, the one I start with, all over f of x sub n, all over f prime. So we start with x, the function of x, and then the derivative of x. So it kind of goes in an order. Okay, x, f of x, f prime of x, and that's minus. So we kind of derive it. Okay, so let's take a look at an example here. And this is going to be using Newton's method. Okay. And we want to use Newton's method to solve this equation, x cubed plus 3x plus 1. So we want to find a root for this one. And we're going to, there may be several roots, but we're going to find one in this area about where our approximation is going to be. So let's let f of x equal this. Then we can find the derivative, because remember when we looked at our formula, we had the x sub n, the function, and its derivative at x sub n. So we'll take the derivative f prime of x, so we get 3x plus 3. So we have our function and our derivative. And then we know for each successive term, okay, we would say x sub n plus 1 equals, like I wrote on the last page, x sub n minus f of x sub n all over f prime of x sub n. Okay? And then if we were going to put this in our particular function, x sub n minus, and then I would evaluate this at x sub n, and I would evaluate the derivative at x sub n, and that would give me the different values. So we have to start with a guess. So let's let x sub 1 be negative 0.3. Okay, so that would be my first guess, negative 0.3. So I could put negative 0.3 for x, and then I would, for x sub 1, and I would put that in here. That would be x sub 1. So I would take negative 0.3 minus, and then I would have f of that. I would put that in the function, and then I take f prime of that, divided by that, simplify it, and I would get x sub 2. And then I would put that in, and I would keep going, and these are the values you would get if you did it mechanically. All right? So we're not going to have to do it like that because we have a real nice calculator program to do that. So this is going to be a lot easier for you. So even if you have a hard time following it, the program that we use or the sequence of strokes we use in the calculator will be easy enough for you to do it. And these will be your homework problems. I think they're going to be, 15, 16, 17, and 18. And I'll want you to do some iterations. Now this first value is called a guess, and then the next values that we get are called iterations. And I'd like to see 4 iterations. So you have to write out the 4 iterations. They ask you to round off to 6 places, but I'll just say 4 iterations. Now how are you going to do this? Well, you're going to take a look at exploration number 2 on page 237, and they're going to show you how to do this. So I'm going to run this through, and this will be like I say, take a look at exploration 2 on page 237, and that shows you how you can do this, and that's basically how you're going to do these homework problems. You're not going to have to do a lot of calculations. It's pretty easy. So first of all, in y1 we'll put our function. So if you remember, our function was x cubed plus 3x plus 1, and this is just like the example in the book so you can follow it. And in y2 I put the derivative, and it's easy to take the derivative of that, just 3x squared plus 3. Okay? So that's basically where we're going to start. Now you have a starting point, I think, for your homework problems, where your first guess. They'll tell you what x1 and b. So, and then if I give you a question on this, I'll always tell you what to use for your first guess. So all of our data looks about the same. So I think they tell you what that's going to be. So basically what you do is, in this case, where our x1 was going to be negative 0.3. So once you have these in your calculator, you just go to home screen, second quit. All right? And actually, you kind of have to look at the graph to get a guess. So you try to get a guess on these problems and for where the root is. And they say you can kind of sketch a graph and then kind of get an idea what they look like because you don't have values to try. I should have given you values to try on these. But try them anyway, and hopefully you can come up with something. All right. Just graph them on your calculator and take a look at about where the root is and pick a number close to that. But in this case, we're going to say negative 0.3. So basically what you're going to do is you're going to say negative 0.3, and you're going to store that. So hit stow, down here, stow. That's a little arrow. Remember, that's down here. I should show you that. I don't know if you can see all this here on the calculator. Okay, let me clear that again here. I think you can see everything here now. Okay, so I'll clear that again. And so I go negative here. There we go. Negative 0.3. Oh, clear. Okay. Negative 0.3. And then we'll hit stow. And then we're going to store that in x. And if you press enter, you should get negative 0.3. Now we just put the formula that we had, and that was, all right, x minus, and then remember the formula was f of x, but we don't have that. We have f of x is in our x1, so we're going to go var y vars, var y vars, enter, enter, and that's going to be our f of x. Remember, if you look back, that's where we had f of x. And then that's going to be divided by, if you look at the formula, f prime of x, and that was in y2. So we'll go var y vars, enter, and go down to y2, enter. And then we just store that. We're going to store that in x. So that's going to become the new x. And then press enter. And now that's going to create a loop. So you just keep pressing enter, enter, enter. And there's your 4 iterations. That's all you have to do. It's pretty easy. And if you look over here, these were the answers that they gave us in the book, and you can see how you got your 322324159, 322185603, 322185546, and 546. So now it keeps repeating itself. So this is basically where you want to get. Well, I'm going to ask you to do 4 iterations. So this is your guess, and then I'm going to ask you to do 1, 2, 3. Write down your 4 iterations. And by the 4th one, they should pretty much be stable. So that's all you got to do. So that's a real easy technique. Again, you can take a look at that in Exploration. I think this is Exploration 2, I guess, on the page. And you can see that this was my equation over here. I'll bring this down a little bit so you can see this. And you can see there's your x sub n minus f of n, and that was where our f of n was, and this is our f prime of n. Okay, so it's right there. So it's not a hard technique, it's pretty easy to do. Just take a look at that, and you might want to play it back if you have to. And then try it, and you shouldn't have any trouble. Try the example first and make sure you can get the example to work, then you shouldn't have any trouble. And like I said for a guess, just graph the function, and then try to, see about where the 0 is, and you just have to be like around 1 or 2 units of it, and then the approximation should work. Hope that helps.